Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's the problem for today. For exam P on probability, 5 different bidders are submitting independent bids for a racehorse. They all believe the value of the horse is to be between $100,000 and $200,000, and as a result of that common belief, their bids, while independent, are all uniformly distributed between $100,000 and $200,000. Find the expected value of the difference between the winning, the highest bid, and the lowest bid. And here's the solution. Let us denote the 5 bids by x1, x2, x3, x4, and x5. This is a random sample from the uniform distribution between 100,000 and 200,000 because they're independent and identically distributed. With probability density function equal to 1 over 100,000 for x between 100,000 and 200,000, and 0 otherwise, and the cumulative distribution function f sub x of x equal to 0 for x less than 100,000, between 100,000 and 200,000 is a linear function x minus 100,000 over 100,000, and it's 1 for x more than 200,000. y5 equal to maximum of these bids, this is the winning bid, and y1 equal to the minimum is the lowest bid. The f sub y5 of y, by the way, this is a definition, but of course it's the standard notation for order statistics, so y5 is the highest order statistic and y1 is the lowest order statistic. So f sub y5 of y is equal to the probability that y5 is less than or equal to y, which is the probability that maximum of the 5 bids is less than or equal to y. Because they're independent, because they're independent comes later. Right now we just see that maximum being less than or equal to y, every single one of them has to be less than or equal to y. Those two statements are equivalent. And then we have the property of every single one of them being less than or equal to y is the property of intersection of these 5 events, but the events are independent because these random variables are independent, so every single one of those probabilities, actually the probability of intersection is the product of probabilities, and every single one of those probabilities is just the cumulative distribution function of x evaluated at y, which is y minus 100,000 over 100,000. Because we know that because of independence we can multiply them, this becomes y minus 100,000 over 100,000 to the 5th for y between 100,000 and 200,000, 0 for y less than 100,000, and 1 for y greater than 200,000. Now the survival function is equal to 1 minus the cumulative distribution function, so we can just take the survival function and take its integral to get the expected value. And the expected value, therefore, is the integral from 0 to 200,000. Beyond 200,000, the survival function is 0. That's why we ignore that. And that's equal to the integral from 0 to 100,000 of the survival function of y dy plus the integral from 100,000 to 200,000. And we separate these two because in the first interval from 0 to 100,000, the survival function is 1 minus 0 because the cumulative distribution function was 0 there. So it's 1. And the integral of 1 from 0 to 100,000 is equal to 100,000. Plus the integral from 100,000 to 200,000 of 1 minus y minus 100,000 over 100,000 to the 5th. Okay, well that's equal to, so the integral of 1 from 100,000 to 200,000 is just 100,000. We add this to this other 100,000, we get 200,000. And then we need to take the minus the integral of this y minus 100,000 over 100,000 to the fifth. Well, that's going to be equal to 100,000, not a million. Yes, so let's correct that. It's 100,000, not a million. 100,000 over 6 times y minus 100,000 over 100,000 to the 6. The 6 comes from this exponent here. 1/6 times the function to the 6 to get the derivative to be to the power 5. And this is evaluated from 100,000 to 200,000, so this becomes 183,333.33. On the other hand, the survival function of the first order statistic is the probability that first order statistic is greater than y, which is the probability that the minimum of the 5 random variables is more than y, which is the probability that every single one of them is more than y, and because they're independent, it's just a product of probabilities of each of them being more than y. And that's the survival function of each of them, which is 1 minus the cumulative distribution function. So this becomes 1 minus y minus 100,000 over 100,000 to the fifth, or 200,000 minus y over 100,000 to the fifth, which we get by expressing this 1 is 100,000 to the fifth over the 100,000 to the fifth. Actually, no, I'm sorry. I take it back. It's 1 is expressed as 100,000 over 100,000, and then we combine the like terms inside, and we end up with this. Note also that the formula we derived applies to y between 100,000 and 200,000, while the survival function of the first order statistic is 1 for y less than 100,000 and 0 for y more than 200,000. Therefore, the expected value is the integral of the survival function, which from 0 to 100,000 is the integral of 1, and that just gives us 100,000, plus the integral from 100,000 to 200,000 of 200,000 minus y over 100,000 to the fifth. And that's equal to 100,000 plus negative 100,000 over 6 times 200,000 minus y over 100,000 to the sixth, evaluated from 100,000 to 200,000, and that gives us 116,666.67. And then the difference of the expected values of those two order statistics is 183,333.33 minus 116,666.67, and that's equal to approximately 66,666.66 or 67. It's an infinite decimal, all sixes. Anyway, that's answer D, and that solves the problem. Please remember this is copyrighted material. The problem was created by me and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.